Okay, so what's going to be important is in this process is communication, right? Even more so than we had to have when we were doing this live class. So if something's going on that you're not understanding or you need more time on, let me know in Canvas. All our communication will be in Canvas. There are lots of things going on right now, and I don't want to lose anybody. I want everybody to successfully pass, but I have no idea of knowing all your different circumstances. So you gotta let me know if something's not working uh, or whatever it may be. And we'll use Canvas, right? So we'll use Canvas to communicate that information. Let's just check in real quick. I sent out several days ago, kind of the layout, the plan for how we're going to proceed. Do you have any questions on what's going to happen, right? I mean, I've sent out several videos and things like that. And do you have any questions that we need to talk about?
I have a question.
All right. Okay, let's try that again, and let's just try that again. We had a question, right? Did I lose everybody? Okay. So good. Thanks, Candace. Yeah, and so if you have an audio feedback, the chat's best. So if everybody sees Candace's question in the chat, it says, "Are you going to let us know when tests are?" Yes, but here's the deal, right? I've posted the schedule in Canvas so you know what sections you should be covering. Because see, this meeting that we hold, we're only holding on Mondays and Wednesdays. I guess that's normal for us. But it's not going to be a long meeting. It's not going to be our regular 2.5-hour marathon. So our schedule is in Canvas, and so look that up, and that should tell you what sections you're doing, and it will also list tests, okay, when those tests and quizzes show up. But probably even better than that is everything has a deadline in MyMathLab. So if you're checking your assignments regularly, daily, and you'll see stuff pop up in there, you'll see the tests pop up. And yes, in these sections, I'll try to mention it to you. But in case you miss one of these live sessions, every deadline will be clearly in MyMathLab. So if you're checking that, or MyStatLab, if you're checking that daily, you'll see the deadlines and you'll know what's up. And I'm adding links to all of the assignments so that you have more time to do them. So you don't have to worry about me, throwing something up there tonight and it being due tomorrow. You'll have a week on most everything at least. So just check your deadlines in Canvas. Now, that being said, right, we were in the middle of a test when this all happened. So we had to switch gears on that test. I added extra time to that test, and it's a take-home. All right. So all your tests are going to be take-home. All right. So that and that means you take them at home. You don't have to go to a testing center. You can use your books and your notes. That's just the best we can do. I am not going to torture you with Proctorio or trying to find a testing center, even if they are open. I just need you to get through the tests, do your best. The only thing you can't do is get help from somebody else. Now, you do have a test going right now. Deadlines are shown in MyMathLab. Just give me a +1 in chat, Candace, if that makes sense. If that answered your question. Okay. What other questions do you guys have? And you can try to go ahead and speak with a mic if you want. That's easy. Let me check with Candace. Candace, I see your name here twice. Did you log on a different device, or did you or did you call in? Just curious. Kansas, or yeah, Kansas. Okay. Yeah. Okay. So let's see. I see a couple questions here in chat. Are you having recordings still to help us with our assignments? Okay. So let's talk about that. So how will you see a lecture, a stats lecture, right? So in my stat lab, there are already lectures made up. Okay. Let me see if I can do this. Okay, so I'm sharing my screen again, and hopefully you're seeing that. What I wanted to do was just show you this. So if we go to our course Canvas, right? Okay. So the question is, are you having recordings? So here's what's going to happen. Let's go through the places you will be able to access material. The first one is to go into my stat lab. Are you seeing my screen? Give me a +1 in chat if you're seeing my Canvas homepage on your screen. Just put a +1 in chat, somebody, if you're seeing my. Okay, thank you. All right, so here is where you go for lectures. This is one place. You go to my stat lab. You go to down to multimedia library, and I outlined these in the instructions and in a video. So if you the multimedia library, and you want to select section video lectures. There are your lectures. So just find them, and that brings up all of the lectures for the entire course. And so we're in chapter 6 and 6.2, applications of normal distribution, and you see there's like a 15-minute lecture right there. Okay, so that's something that you will want to watch. Okay, now you'll learn what you can from that. That's one place. All right. The second place are these meetings that we are having right now. My plan for these meetings is to use them to answer your questions. Okay? And if you don't have questions, then I will work through examples. Okay? So that's what these sections are for. I'll just be working through examples from the section and talking about it. These are being recorded, and they will be posted in Canvas. So let's go back to our Canvas page. And so if you go to your complete online module, this is where you'll find everything related to the stuff we're doing online. You will see right here, there's all your Stat Lab module stuff. But up on top, there's this new module now. So there's this new module now. There's the plan. If you have a question about anything, check that. But these lectures or these meetings that we're having right now, I'll get them uploaded to this link right here, recorded tutorial sessions, because that's what this is. This is a tutorial section, right? And so they'll be there. So that's another place you'll learn the material. Another place is I hope to be able to create just one-off samples. And there's these example videos. I'm just going to try to create as quickly as I can just examples from those sections and post those. I've only got one up there for this section right now, but there's another place where you'll find examples that cover the material. All right, so there's that right there. All right, so those are the places you will go to learn the material. And then, of course, after every section, there'll be a homework assignment covering that section. Okay, but as you work through this, this section that we do on Mondays and Wednesdays is my office hour. It'll be the time when I'm available, designated to help you. Now, if we need more, if we need more time, then we can set up other times. But right now, this is a designated time where you can come and ask questions. To make use of this time most effectively, you're going to want to make sure you come prepared with questions. Okay. Now, so that when we get started, hopefully after these first couple times, we will have all of the technical issues ironed out. We'll just be able to jump right in. Come with questions, bring them, and ask them. All right. You maybe don't have any questions or feel good about what you're understanding. There's a good chance, though, that if you come, you'll learn something anyway. So what we're doing on these Mondays and Wednesdays at 1:30 is optional, but I encourage you to be here so you can ask questions and participate. All right. So that's kind of a little bit about, just looking back at chat, a little bit about my office hours. We're going to have them right now. I'm using this time right now for office hours. I might add additional time as we go along. And then where you learn the material. Okay, are there recorded lectures? And these things are going to be recorded plus the examples that I work on. Okay. I also see another question about Top Hat. Right now, I'm going to continue to distribute the slides via Top Hat, and they'll give you some things to work on. We'll see if I have time to give you questions on Top Hat. I don't know. That may be one of those things that I wish we could have done more of, but it may be just have to go by the side as we try to just get these other things going. I'm more concerned. Please don't use Top Hat, or please don't not use Top Hat. I think I know what you mean. Yes, it would add a little just extra stuff that you got to keep track of, and I don't want to do that. So I think there's a good chance that all I'll be doing is distributing the slides via Top Hat for you to use. Okay. All right. It's just maybe one of those things we've got to change. So, but watch Top Hat for the slides. I guess I can at least say that. But that's no sweat off of you guys, because that's just they're available. Okay. Other questions? Do you guys have other questions on these things? In fact, I'm going to send out the Top Hat slides right now. Okay. If you think of other questions, let me know. But for now, I'd like to work a couple problems so you can see what we're doing in this section. Can you go back in your Files tab and see the slides? You mean in Top Hat? Can you see the slides in Top Hat? Is that what you're asking? I just submitted the most recent slides for today's stuff. Okay. So, all right. So I'm going to do this. I want to show you some examples. But if you think of other questions, let me know. Because that it's going to take us a little while to get a system up and rolling. Right? It's brand new. But we want to. I don't want to lose anybody along the way. So let's see. Okay. Oh, can you put the slides on Canvas? Yeah, I can probably do that. Okay, let's get rolling. All right. I might do some other things. I mean, we'll just see. But whatever I do, the goal is to make your life a little easier so that you can learn the material. So, anyway, I want to show you some examples from what we're doing in this section, in section 6.2. So I'm just going to work through several of the problems in the textbook, all right, and demonstrate what it is that we're doing. I want you to remember this, though. First of all, this lecture is recorded, right? These are being recorded, so if you get cut off or you miss them or whatever, the goal is to have them available to you anytime you want them. All right. Show to your friends. You know, I mean, you can have a lot of time alone. This is what we did in the last section, if you can remember, right? We took a normal distribution and we established like a boundary, and then we worked on finding the area on either side of the boundary. So maybe we found it on the left side, or maybe we found it on the right side. And of course we used the z-score, right? The boundary had a z-score, and then we used the table, I think it was table A2, to find the area. That's what we did, right? To find this yellow area. Or we used our calculator, okay? I want you to know something about 6.2. We're going to do the same thing. But we're going to do it with real-world problems. So in other words, these are going to be problems that this is where we really use this idea. So I want to show you what I'm talking about. Let's take a simple problem. All right. I want to do this one right here. This is an odd topic, but this is the let's see, how do they describe it? These are the back to the knee length. So if you're designing chairs, so I'm going to write this down. And you should be seeing my screen. Let me know. Let me know if you're not seeing what I'm writing here. So what we're talking about is the back to knee length. So if you're sitting in a chair, right, you think about, how big the seat's got to be from the back to your knee. All right, so that's what we're talking about. What is it? We're talking about person's back to knee length. What's the distance from their back to their knee when they're sitting down? The reason this would be important is because, if you're designing chairs, you want the chairs to be comfortable to people. If the seat is too short, then people feel like they're sitting on a little tiny, board. If it's too long, then they can't even bend their legs. Their legs are going to be out straight, right? So when I'm talking about back to knee length, let's do an illustration, right? This is what you get in an online class, right? There we go. He's waving at you from his social isolation chamber. We're talking about this length right here, okay? And so if we want to design chairs that fit people, then we've got to figure out, how long should we make the seat? How wide should we make the seat? So here are some facts. For males, the mean length, the mean back to knee length, we'll just call it the length, is 23.5. So that's the average, and they probably have that number from tons and tons of data with a standard deviation of 1.1 inches. Okay? So there you go. And these are normally distributed. This length is normally distributed. All right? All right, so here's the kind of question you're going to see. If we choose a person at random, find the probability that a male has a length less than 21 inches. Okay? All right, so this is where you're going to see some things that look familiar. The lengths that we're talking about are normally distributed with a mean. With a mean of 23.5, right? So there's the distribution for these lengths. We're trying to find the probability, let me write it in notation, the probability that a man has a length less than 21 inches. Okay, so that's what it would look like in our notation. Okay, so what that means is we put our boundary at 21. Bam, 21. And we want to find the probability of being less than that, so we want to find this area. All right? So all of these problems you're going to see in this section are the same idea. Here's a normal curve with a mean. There's going to be some boundary, and you need to find the area. All right? So that's going to be very, very similar to what we've already done. All right, so we just need to find that area. Now, here's the deal. To find these areas, we need to use table A2. But table A2 requires our boundaries to be in z-scores. So that's what we're going to do. The first thing we need to do is we need to find the z-score of our boundary. Convert it to a standard normal score. All right, so convert 21 to its z-score. And we do that using this formula, right? Z equals the data point minus the mean over sigma. That's the z-score that we've been using all along. So for our case, z is 21, because that's the boundary, minus the mean over sigma, which is 1.1. All right? And you know what? You guys are off the hook, because I guess I got to do all the calculator work. That's the real tragedy. So negative 2.27. That's the z-score. Let's put it in here. Negative 2.27. Okay, so once you have the z-score, you can now look up the area in your table. And this is a left area, so we can get it right from the table. So we go to our table and look up at the negative z-scores, negative 2.27, and hopefully you're following along, or you'll follow along, and I get 0.0116. 0.0116. That's from the table, and that's my area. And that is the probability of getting a male with a length less than 21. That's about, what, 1%, a tiny little bit over 1%. That's not very much. So there's just about a 1% chance that you will find a male that has a shorter length than 21. Okay? All right, give me some pluses in the chat if that makes sense to you. Just put a plus in the chat, or a minus if it doesn't, or an equals to if you're, thumbs sideways kind of person. We're going to do another problem here. But I'm seeing, so Felicia still has a question, right? And that's okay. This is the first time seeing it. So let's do another one. And, you'll see a lot of the similarities. So these are kind of problems you're going to look at. So let me throw another problem out here. Here we're dealing with Navy pilots. Okay? Navy pilots. All right. So Navy pilots. And here's what we know. Men's height, so these are just any men. Men's heights have an average of 68.6 inches and standard deviation of 2.8 inches. Okay, so we know, and they're normally distributed. So we know that if we look at the distribution of men's heights, the mean will be right there in the middle, 68.6. And of course we know that distribution means that most of our people live in that region, right around average, right? That makes sense. But here's the question. The Navy has a height requirement, right? Because they've got to be able to fit into planes. And the height requirement is this. People must be between, in order to get in to be a Navy pilot, between 62 inches and 78 inches tall. Otherwise, they just won't fit, right? And so the question is this. What's the probability, or find the percentage of people that fit between 62 and 70? All right? So those are the same kind of questions. What percent of men have heights between 62 and 78? Right? That's the question. What percent? That's the same as this. I'll write it down. Sometimes they might ask the question like this. If you choose a person at random, what's the probability that their height is between 62 and 78? right? That's the same kind of thing. But what percentage of men have heights between 62 and 78? So look what happens. We go over a distance 62. There's our 62 boundary. 78 is, I don't know, somewhere maybe up here. There's our 78 boundary. And look, we need to just find that area between the boundaries. So you see the similarities between all the problems we've done. Put a couple boundaries on the problem, on the normal curve, and then find the area between them. All right, so that's what we're doing. So we just need to find this area. Now, the key here is no matter what method you use, you want to convert to